Hello students, hope you all are doing well. So here in this video, we are going to talk about the reactions that you find in organic chemistry. Regarding alkenes and alkynes, they are the unsaturated hydrocarbons. What about alkanes? They are saturated hydrocarbons. Therefore, it's only unsaturated hydrocarbons, alkenes and alkynes exhibit these reactions. Which reactions? It's the hydrogenation. What is the hydrogenation? Hydrogenation simply is the addition of hydrogen on a substance, on a molecule. When you get hydrogen molecules being added, it is a hydrogenation. So we are going to talk about the hydrogen addition. We are going to let them react with hydrogen. So it's alkenes and alkynes, they lack hydrogen. They do not have the maximum number of possible hydrogens that they could have. It's alkanes do. So then we are going to transform these alkenes and alkynes into alkanes. In that aspect, you could name these reactions as the reactions that alkanes, the reactions you use to form alkanes. Synthesis of alkane, you could talk about this reaction under that category. Synthesis of alkanes, as well as it belongs to another category that you could use them under reactions of alkenes or reactions of alkynes. Okay, let's first find out the reaction that alkenes exhibit. Regarding this, it's students, when you have carbon-carbon double bond in a hydrocarbon, we call an alkene. These alkenes, they react with hydrogen gas when you add the catalyst, either platinum or palladium or nickel. So all are solid metal surfaces. So hydrogen would be absorbed by the solid metal surfaces, and then these alkenes would go there and react. So when it is nickel, it is a nickel coating there. You could find with the catalyst, as we then name it as the Rene nickel. Okay, so then students, when you let them react, you will find those earlier bonds that you have got are still there as they are. Then this pi bond opens up, means cleaves, means breaks, giving you two edges at two ends. So it's the reaction that you get. During this reaction, you get one H2 molecule being added there. Addition of H2 is hydrogenation. That's why we call it a hydrogenation reaction. Okay, and it is the hybridization when you consider, it is 1, 2, 3, the number of repulsion units there. Therefore, it is with 1s, other 2 it means of P, so sp2, the hybridization that exhibit by this carbon 2. It is sp2 hybridized. When you check for this carbon now, it is 1, 2, 3, 4 repulsion units you get. Therefore, it is with 1s, other 3 P you need. It is sp3 hybridized. Therefore, during this reaction, you could find the hybridization state get changed from sp2 to sp3. Okay, then let's take an example reaction. I'm going to talk about the very first alkene in the alkene family. So the simplest one is ethene. This is ethene. So when you let ethene react with hydrogen in the presence of any of those catalysts, let's use platinum. When you let ethene react with hydrogen in the presence of platinum catalyst, you would find all the earlier atoms were still there. Then this pi bond opens up, giving a chance to attach these two edges from H2. That's what the reaction. So it is an addition of hydrogen, so it is hydrogenation. Addition of hydrogen is called hydrogenation. Then when you check for the hybridization state, it is sp2 to sp3, the change taken place. And when you further check for the oxidation state, you will find here in this ethene, it's between these two carbon, the electronegativity difference is 0, no electronegativity difference. But between the carbon and hydrogen in that bond, you would find carbon being slightly more electronegative than hydrogen. Therefore, a slight negative charge slight positive charge here, you get. They are regarding this bond also slight negative, slight positive. The charge difference you get. So it is a partial taken of an electron from hydrogen by carbon. So it's 2 such. Therefore -2, the oxidation state of this carbon you get there. So here when you check, it's some such slight negative, slight positive, you will get 3 of them. It is then -3 the oxidation state of this carbon. So the oxidation state going to get changed from -2 to -3. It is a decrease, it is a reduction. So this is going to get reduced during this reaction. It is a reduction reaction of hydrogenation. Hope you got that. Okay, let's find out another example. If students, I will take the next member in the series of alkenes. It's propene. So when you let propene react with hydrogen in the presence of any of those catalysts, let's use nickel. When you use nickel as the catalyst, so you get still the same similar product as of earlier. It's all the earlier atoms still would be there, and this pi bond going to get open up and giving a chance to this 2 H's from H2, you will get a hydrogen molecule being added there. It is a hydrogenation. Therefore, here it is sp2, sp3, the hybridization change from sp2 to sp3. Then further, when you check for the oxidation state, here the carbon, the difference is 0. Here the carbon difference is 0. You could find the only difference you get here in this one, slight negative, slight positive, as it was earlier. Therefore, it is partially taking an electron from hydrogen. Therefore, it's -1 the oxidation state of this carbon. When you check it for this carbon, so it's between these 2 carbon, it's 0 the difference. These 2 carbon also 0 the difference. It is -1 due to the slight negative, slight positive, slight negative, slight positive dipoles. So it is -2 the oxidation state. It has got changed from -1 to -2. It's a decrease, therefore a reduction. So these hydrogenations you could call reduction reactions, as well as changing of hybridizations from sp2 to sp3, as well as addition of hydrogen molecules. Then let's go to alkynes context. When you check for alkynes, you are going to have, it's the same catalyst and same reagent, H2 that we are adding. So I will be leaving those them as they are. So in an alkyne you will get these triple bond. Then students, you will get 2 pi bonds here. Both pi bonds going to get be broken. It's going to get opened up, giving chance to 2 H2 molecules. 2 H2 molecules provide 4 hydrogen atoms. So those carbons will get 4 hydrogen atoms, so an alkane would be formed. Okay, so when you check for the hybridization state here, it is 1 repulsion unit, another it is 2 repulsion unit. With 1 S, another P only it needs, so it's Sp the hybridization. When you check it for this one, it is 1, 2, 3, 4 the number of repulsion units 4, with 1 another 3 of P you need, so it is Sp3 the hybridization. So then its hybridization going to get changed from Sp to Sp3. Then let's take a look at an example reaction. It is the first member is ethyne. In application, the trivial name we call it acetylene. So let's use one catalyst out of them. It's palladium I'm now using. So you could use any anyway. So you are going to have all the earlier atoms still. Then newly, those 2 pi bonds are going to get opened up and giving a chance to another 4 hydrogen atoms like this. So the hybridization, still the change of hybridization is same as from sp to sp3, and its addition of 2 H2 molecule as it was earlier. So now the oxidation state here, it is no difference, but here it is -1. Given by this bond. So it is -1 the oxidation state of that carbon. Here when you check for that, it is -3 the oxidation state. It's a reduction reaction. It's reductions all the times having there when you talk about the hydrogenations. Then students, you would find the fact that when you have this problem, it being problematic whether you could stop this reaction after formation of an alkene by this. What I mean? I meant was this. It is after forming, after breaking into one hydrogen. Can't you stop this reaction? Can't you stop this reaction? It is apparent like you would use this reaction to form alkanes. So, can't you use this reaction to form alkenes as well? The answer is can. Can. There is one way of doing that. It is when you specially use this catalyst, palladium. Palladium, you could weaken the catalytic action by toxicating the catalyst. So you could toxicate or poison the catalyst by adding quinoline. It's in quinoline medium. Quinoline medium. You need to add barium sulfate. Add the catalyst palladium in the presence of barium sulfate in quinoline medium. Then treat that with H2O. Then it is partial hydrogenation will be taking place. It won't be gone to alkane. So this incident or this reagent we call the Lindlar's catalyst. Lindlar's catalyst or reagent. So yes, you could stop the reaction after formation of alkene as well. Then students, I'm going to talk about another example. It is the second member with 3 carbons. So when you use H2 in the presence of nickel, you are going to have propane, the respective alkane. So here it's in one hand hydrogenation, therefore hydrogenation. In another aspect, it's changing of, in the context of alkynes, changing of the hybridization from sp to sp3, and from when it is about alkenes, sp2 to sp3. Then in both, it is a reduction reaction. Okay, so in one hand, it is a synthesis of alkanes, or sometimes for alkenes also you could apply this. In the other hand, it's reactions that alkenes exhibit as well as alkynes exhibit. Okay, hope you would understand these few simple things. So, it's the end of the video. We are going to round up here and meet you in our next video talking about another similar reaction that in organic compounds you would experience. Okay students, it's goodbye.